Imagine a blazing summer day. The sun is shining at its peak, and you might think, this must be perfect for my solar panels, right? After all, more sunlight should mean more power. But here's the twist. While solar panels love sunlight, they absolutely don't love heat. In fact, as temperatures rise, their performance often takes a hit. Surprising, right? This counterintuitive effect is tied to something called the temperature coefficient of solar panels. So let's dive in to uncover the science behind it and explore what we can do to keep solar panels performing at their best. First, how does the temperature coefficient work? The idea is simple. For every degree increase in temperature, solar panels lose a percentage of their power output. Why? Because higher temperatures reduce the voltage that the panels can generate. Although there is a slight increase in current, the overall power still decreases. Let's take an example. This solar panel model has a temperature coefficient of negative 0.35%. That means for every degree above 25 degrees Celsius, its power output drops by 0.35%. So if the temperature rises from 25 degrees to 35 degrees Celsius, this panel's efficiency decreases by 3.5%. And most solar panels on the market have coefficients ranging between negative 0.3% and negative 0.5% per degree Celsius. Now, you might think, a few degrees don't seem like much. But here's the reality. On a hot summer day with direct sunlight, the temperature of solar panels can soar to 60 degrees Celsius or more, even when the air temperature is just 30 degrees Celsius. For a panel with a temperature coefficient of minus 0.5%, that could mean a 20% loss in power output, compared to operating at a cooler 20 degrees Celsius. So, does this mean colder regions are better for solar panels? Well, yes and no. Colder climates do reduce efficiency losses because of lower temperatures, but colder regions often have other challenges, like frequent snowfall and lower solar radiation levels that can offset the benefits of cooler weather. Now, what's the science behind this? The temperature coefficient is tied to the physics of semiconductors, the material that makes solar cells work. Here's what happens. As temperatures rise, the energy gap in the semiconductor, called the band gap, narrows, reducing the voltage solar cells can produce. Higher temperatures also cause more electrons and holes to recombine, canceling out instead of generating electricity. Put these two effects together and you get a noticeable drop in efficiency.
Yes, science!
So, what can we do to reduce heat-related losses? You could set up fans to blow air directly onto the panels, or even consider placing ice packs on them during peak heat hours. I'm just kidding. The real solution lies in ensuring good airflow around them. Proper ventilation allows heat to dissipate more efficiently, keeping the panels cooler. For ground-mounted panels, it's important to leave sufficient clearance from the ground to encourage air circulation. Similarly, for rooftop systems, using specialized mounting brackets to create a gap between the panels and the roof can make a significant difference. Another effective measure is to choose solar panels with a lower temperature coefficient, checking the technical specifications before purchasing. For instance, the Longi panels we discussed earlier, with a coefficient of negative 0.35%, are not a bad option. Lastly, consider using bifacial panels. These advanced panels can absorb sunlight from both sides, which not only increases energy generation, but also enhances heat dissipation, making them a smart choice for hot climates. Understanding the temperature coefficient can help you get the most out of your solar investment. Choosing the right panels, designing systems with proper ventilation can all make a difference. Thanks for watching, and I'll see you in the next video.